Hello everyone. In the previous session, we studied about high frequency response of common source amplifier. In this session, we'll study about the low frequency response of common source amplifier. So, for the analysis of common source amplifier in its low frequency band, the DC sources, if any, present in the circuit of the common source amplifier must be eliminated, and the current sources, if any present, must be open circuited. So here we have, this is the configuration of common source amplifier. Here we have a current source, so this must be open circuited. And next, if there are any DC sources, it must be eliminated. So there are no DC sources in this configuration, so let's not worry about it. And next, the supply voltages, that is VDD and VSS, must be short circuited. So after doing all these modifications to analyze the CS amplifier in its low frequency band, the circuit will be modified as shown here. Okay, current source is open circuited and VSS and VDD are grounded. So now the voltage at this gate terminal, that is across the resistor RG, will be equal to V signal into RG by R signal plus impedance across its coupling capacitor is given by 1 by S into CC1 plus RG. Okay, so this is it. And next, the frequency response of a common source amplifier in its lower band, if you zoom it, the frequency response will be as shown. The gain will gradually increase. Okay, the low cutoff frequency is mainly affected by the three RC networks that is present in the circuitry. Okay, so what are the three RC networks? See here, F1 is given by 1 by 2 pi CC1 into R signal plus RG. So coupling capacitor and this RG and R sig, this will form one RC network, isn't it? So this RC network will affect the low cutoff frequency. Low cutoff frequency can be F1 or F1 dash or F1 double dash. So due to this RC network, low cutoff frequency is given by F1 is equal to this. And next, due to this RC network, CS, wait, the reduced, yeah. So this is one more RC network on this capacitor, and the resistance internal to the MOSFET will form one more RC network. And due to this, we have one more equation for low cutoff frequency. This RC network will determine, or it will have an effect on the low cutoff frequency, and that is given by F1 dash is equal to Gm by 2 pi CS. And next, this coupling capacitor CC2 along with RD and RL will form one more RC network and will have an effect on the low cutoff frequency, that is given by F1 double dash, that is equal to 1 by, just write CC2 in place of CC1, and RD and RL. The resistances at the output side is RD and RL. The resistances at the input side is R signal and RG. So that R signal, RG and coupling capacitor CC1 will form one network. CS along with the resistances internal to the MOSFET will form another network, and RD and RL along with CC2 will form another network. So these three networks will have an effect on the low cutoff frequency. So out of all these frequencies, whichever is the highest frequency will be the low cutoff frequency. Say F1 dash is higher than F1 and F1 double dash, F1 dash will be the low cutoff frequency. If F1 is higher than F1 dash and F1 double dash, F1 will be the low cutoff frequency for the CS amplifier. And the overall frequency transfer function of the amplifier can be found by the above three equations. It is very complicated actually. The calculation and all is not included here. V naught by V signal is equal to minus Rg by Rg plus R signal, that is due to this, and we have Gm into Rd parallel R naught, Gm into Rd parallel R naught, Rd parallel RL. R naught is not there because R naught is having negligible effect in determining the low cutoff frequency. And next, S by S plus omega 1 is due to this frequency component F1, and multiplied with S by S plus omega 1 dash is due to this frequency component F1 dash, and S by S plus omega 1 double dash is due to this frequency component F1 double dash. So this is the overall voltage gain of the circuit. Next, we have a problem on this, wherein a coupling capacitor CS and coupling capacitor 2 is equal to 1 microfarad, Rg is equal to 12 mega ohm, R signal is equal to 180 kilo ohm, Gm is also given, Rd is also given, RL is also given. We need to find out AM, that is a midband gain, F1, F1 dash, F1 double dash, and FL. So AM, we know the equation, minus Rg by Rg plus R signal into midband gain formula. This is. So by substituting all the parameters, we'll found out that AM is equal to minus 7.09, and F1, F1 dash, and F1 double dash formulas are known. Upon substitution and the simplification, we'll get these values for three frequencies. Out of these three frequencies, we have got highest value for F1 dash, isn't it? So this particular frequency will be the low cutoff frequency. See here, F1 dash is greater than F1 double dash and F1. Therefore, FL is equal to F1 dash, which is equal to 190.98 Hertz. So this is what the frequency response of the common source amplifier.